This is just another vector problem. The next section we're getting into is forces. And forces are vectors, so we still need to remember how to work with vectors. So here in our diagram we have three forces acting on an object. The question is what is the net force on the object? By net force, we simply mean the sum of the forces. So we need this plus this plus this. So if we call this vector A, it has an x component of 4 and a y component of 4. Now the units, these are the units, they're newtons. A newton is a kilogram times a meter over second squared. We'll talk more about that later. But just so you know, the unit of force that we're going to use is a newton. Vector B over here has an x component of -2 and a y component of 3. Vector C has an x component of -3 and a y component of -2. So we're simply adding these together to get the net force. Four minus 2 minus 3 is -1. 4 plus 3 minus 2 is 5. So that is our net force in vector notation. To represent net force, it's the summation of the forces. The problem asks for the magnitude and direction though, so we need to take this another step further. So our vector points to the left by 1 and up by 5. So that's our net force vector right there. Magnitude, Pythagorean theorem, 1 squared plus 5 squared square rooted gives us 5.1 newtons as our magnitude. This angle can be found using the inverse tangent of 5 over 1, which is 79 degrees. But remember, we can't leave it at 79 degrees. If we just said 79 degrees, that would imply it was in the first quadrant. So our answer is 5.1 newtons. We could say 79 degrees above the negative x-axis. That would be fine. Or we can subtract that from 180. 101 degrees is fine as well. So 101 degrees or 79, above the negative x-axis. You would not write it in terms of north, south, east, or west, because the problem is not written in terms of north, south, east, or west. Okay. If the problem describes things in terms of north, south, east, west, then you can write your answer in terms of north, south, east, and west. But if it doesn't, you can't assume that it is north, south, east, or west. So just relative to the axis is fine as well.